Hello students, welcome to the Department of Collegiate and Technical Education. Today we are going to discuss about the very important component which is widely used in the field of electronics, that is op-amps. So in this session we are going to discuss about the basic definition of op-amp. Op-amp andre ಏನು, what are the detailed blocks of op-amp ಅಂದ್ರೆ block diagram ಅದ್ರ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ತೀವಿ. At the same time we are going to discuss also about the operation of operational amplifiers. So as I said in this session, the definition, block diagram and operation of operational amplifiers we are going to discuss in this session. So to start with, op-amps, that is operational amplifiers, they are nothing but linear devices. So linear devices andre ಏನು? Linear devices andre output ಮತ್ತೆ input ಮಧ್ಯೆ ಒಂದು definite relationship maintain ಆಗಿರುತ್ತೆ. ಅಂತ devices ಅನ್ನ ನಾವು linear devices ಅಂತ ಕರಿತೀವಿ. So operational amplifiers are one such linear devices. So ಇದ್ರದ್ದು ಏನ್ ಪ್ರಾಪರ್ಟೀಸ್ ಏನಿದೆ, ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಏನಿದೆ, which are very much close to the ideal characteristics. So they are very much suited for ideal DC amplification. Hence they are extensively used in signal conditioning, filtering, at the same time to perform many mathematical operations such as addition irbodu, subtraction, integration, differentiation, summing. So all such mathematical operations can also be performed by operational amplifiers along with amplification. Hence they are named operational amplifiers. So bari amplification ಒಂದೇ ಅಲ್ಲ, ಅದ್ರ ಜೊತೆಗೆ ಈ ನಮ್ಮ ಆಪರೇಷನಲ್ ಆಂಪ್ಲಿಫೈಯರ್ಸ್ ಕೆಲವು ಮ್ಯಾಥಮ್ಯಾಟಿಕಲ್ ಆಪರೇಷನ್ಸ್ ಕೂಡ ಪರ್ಫಾರ್ಮ್ ಮಾಡೋದ್ರಿಂದ ನಾವು ಇದನ್ನ ಆಪರೇಷನಲ್ ಆಂಪ್ಲಿಫೈಯರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಡೆಫಿನಿಷನ್, ಆಪರೇಷನಲ್ ಆಂಪ್ಲಿಫೈಯರ್ ಅನ್ನ ಯಾವ ತರ ನಾವು ಡಿಫೈನ್ ಮಾಡಬಹುದು ಅಂದ್ರೆ, ದೇ ಆರ್ ಬೇಸಿಕಲಿ ಮಲ್ಟಿ ಸ್ಟೇಜ್ ಆಂಪ್ಲಿಫೈಯರ್. ಸೊ ಇಟ್ ವಿಲ್ ಹ್ಯಾವ್ ಮೆನಿ ಸ್ಟೇಜಸ್. ಸೊ ಮೆನಿ ಸ್ಟೇಜಸ್ put together will become one operational amplifier. So uses number of amplifier stages which are direct coupled to each other. So please make a note of it. The stages of the operational amplifiers, they are direct coupled. Andre blocks called multi stages, they are connected directly without any coupling capacitors. Hence they can be used for amplification of both AC as well as DC signals. So ಯಾವ್ದೇ coupling capacitors ಅನ್ನ ಯೂಸ್ ಮಾಡದೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ನಾವು ಸ್ಟೇಜಸ್ ಅನ್ನ, ಮಲ್ಟಿ ಸ್ಟೇಜಸ್ ಅನ್ನ ಕಪಲ್ ಮಾಡಿರ್ತೀವಿ. ಕಪಲ್ ಅಂದ್ರೆ ಕನೆಕ್ಟಿಂಗ್ ಅಂತ. ಸೊ ಯೂಶಲ್ ಆಗಿ ನೀವು ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಆಂಪ್ಲಿಫೈಯರ್ಸ್ ಅಲ್ಲಿ ನೀವು ನೋಡಿರ್ಬೋದು, ಯಾಕೆ ನಾವು why we consider multi stages in order to obtain more of amplification, more of gain. So we connect multi stages. So multi stages ಅನ್ನ connect ಮಾಡುವಾಗ ನಾವು capacitors ನ most of the time we use capacitors for coupling different stages of an amplifier. So you might have seen in transistor when it is used as an amplifier. But in case of operational amplifiers, they are direct coupled without any coupling capacitor. So basically an op-amp, it consists of two input terminals, one output terminal and two supply voltage terminals. As you can see here, so as you can see in this picture, it consists of two input terminals. One is named non-inverting input, that is plus symbol. The other is the inverting input, that is negative symbol. So one output across which you get the amplified voltage or current. So for the operational amplifiers to work efficiently, it requires both the positive as well as negative voltages for their operation. So ನೀವು ಇನ್ಪುಟ್ ನಲ್ಲಿ ಏನ್ ಸಿಗ್ನಲ್ ಕೊಡ್ತೀರಾ, the signal to be amplified, it always swings between this plus voltage and minus voltage. ಅಂದ್ರೆ ಈಗ ಆಪರೇಷನಲ್ ಆಂಪ್ಲಿಫೈಯರ್ಸ್ಗೆ ನೀವು ಪ್ಲಸ್ 12 ವೋಲ್ಟ್ಸ್ -12 volts ಕೊಟ್ಟಿದ್ರೆ ಸಿಗ್ನಲ್ ಟು ಬಿ ಆಂಪ್ಲಿಫೈಡ್ ನೀವೇನ್ ಇನ್ಪುಟ್ ಅಲ್ಲಿ ಕೊಡ್ತಾ ಇದ್ದೀರಾ ಅದು +12 ಮತ್ತೆ -12 ಮಧ್ಯೆ ಮಾತ್ರನೇ ಆಂಪ್ಲಿಫೈ oscillate ಆಗ್ತಾ ಇರುತ್ತೆ, not beyond that voltage. So they require both positive as well as negative supply DC voltages for their operation. So the op-amp amplifies the difference between the two signals and reject common signals. So as you can see here, since we have two inputs, one non-inverting and one inverting, the ಎರಡು ಟರ್ಮಿನಲ್ಗೆ ಅಪ್ಲೈ ಏನು ವೋಲ್ಟೇಜ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ ಅದರದ್ದು ಡಿಫರೆನ್ಸ್ ವೋಲ್ಟೇಜ್ is amplified. ಸೊ ಕಾಮನ್ ವೋಲ್ಟೇಜಸ್ ಏನಿದೆ ಅದೆಲ್ಲ ರಿಜೆಕ್ಟ್ ಆಗುತ್ತೆ. They are rejected by the amplifier. Only the differential voltage is amplified by the amplifier. So as I said, the input terminal marked with negative sign is called an inverting terminal. That is this one, inverting terminal. So if we connect the input signal to this terminal, the amplified output signal will be 180 degree out of phase with the input. Andre inverting terminal nalli ನಾವು ಏನೇ input apply ಮಾಡಿದ್ರು output ಅಲ್ಲಿ we get the inverted output, that is 180 degree phase shift ಆಗಿರುವಂತಹ amplified output ನಮಗೆ ಸಿಗುತ್ತೆ. Similarly, when you apply voltage ಅಥವಾ signal to the non-inverting input, that is plus indicate ಆಗಿರುವಂತಹ input terminal ಗೆ, if we apply the signal to be amplified, output ನಲ್ಲಿ we get the amplified output which is in phase with the input, So now let us discuss about the various blocks of the operational amplifier. As you can see, this is the input stage, this is the intermediate stage, and this is the output stage. So intermediate stage consists of more number of stages. So the first stage is the differential amplifier, the input stage of the operational amplifier. It consists of differential amplifier. So input stage, as I said, which is a differential amplifier which operates in the differential mode. So different modes, input modes ಬಗ್ಗೆ ನಾವು later we will discuss about that. As of now, concentrate on the input stage, which consists of a differential amplifier which operates in the differential mode. So the inputs are noted with plus and negative. So this stage provides most of the voltage gain of the operational amplifier, and they also decides the input resistance of the operational amplifiers. So input resistance ಎಷ್ಟಿರುತ್ತೆ ಅದೆಲ್ಲ ನಾವು characteristics ಬಗ್ಗೆ ಓದುವಾಗ we will discuss about that. So the input stage, it consists of a differential amplifiers with two inputs, and this stage provides most of the voltage gain of the operational amplifier. Gain andre ನಿಮಗೆ ಗೊತ್ತೇ ಇದೆ, gain ಅಂದ್ರೆ ಏನು? It is the amplification capacity of the amplifier. ಅಂದ್ರೆ ಔಟ್ಪುಟ್ ಎಷ್ಟು ಆಂಪ್ಲಿಫೈಡ್ ಆಗಿ ಇನ್ಪುಟ್ ಗಿಂತ ಎಷ್ಟು ಇನ್ಕ್ರೀಸ್ಡ್ ಆಗಿ ಎಷ್ಟು ಆಂಪ್ಲಿಫೈಡ್ ಆಗಿ ನಮಗೆ ಔಟ್ಪುಟ್ ಅಲ್ಲಿ ಸಿಗ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ಡಿಸೈಡ್ ಮಾಡೋದು ಗೇನ್ ಫ್ಯಾಕ್ಟರ್. ಸೊ ಗೇನ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಔಟ್ಪುಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಇನ್ಪುಟ್. ದಿ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಸ್ಟೇಜ್, ಮಧ್ಯಂತರದಲ್ಲಿರುವಂತಹ ಸ್ಟೇಜ್, ಇಟ್ ಆಲ್ಸೋ ಕನ್ಸಿಸ್ಟ್ಸ್ ಆಫ್ another differential amplifier which is driven by the output of the input stage. ಅಂದ್ರೆ ಮೊದಲನೇ ಸ್ಟೇಜ್ದು ಔಟ್ಪುಟ್ will drive the input of the intermediate stage, and these stages, they are direct coupled. As I said in the starting of the session, operational amplifiers, they are direct coupling. They don't use any capacitors to couple the stages of the operational amplifier. So direct coupling ಆಗಿರೋದ್ರಿಂದ the DC voltage, the level of the DC voltage at the output of the intermediate stage would be shifted above the ground potential. Zero potential ಗಿಂತ ಜಾಸ್ತಿಗೆ shift ಆಗಿರುತ್ತೆ because of the biasing voltages. Therefore, the DC level at this stage must be shifted down to 0 volts with respect to the ground. Hagagi, intermediate stage, most of the situation will have a level shifting stage also. So which is usually an emitter follower. So emitter follower na ನಾವು level shifting stage ಆಗಿ use ಮಾಡಿರ್ತೀವಿ. Output stage, it provides the current supplying capability ಅಥವಾ current supplying capability of the operational amplifier is increased by the output stage. So output stage ನಲ್ಲಿ usual ಆಗಿ push pull amplifier use ಮಾಡಿರ್ತೀವಿ. So this push pull amplifier increases the output voltage swing of the signal, and it also increases the current supplying capability of the operational amplifier. So an operational amplifier, it consists of an input stage, which is a differential amplifier, 2 input and balanced output, and it also consists of intermediate stage. Intermediate stage nalli again you will have one more differential amplifier and also level shifting stage, and the last stage, that is the output stage, which consists of a push pull amplifier, which increases the current supplying capability of the operational amplifier. So this is the symbol of an operational amplifier. As you can see, it consists of 2 inputs, 1 output and 2 supply voltage terminals, and the 2 inputs are the non-inverting input and the inverting input. Now let us discuss about the various modes of operational amplifiers. Andre operational amplifiers ಗೆ ನೀವು ಯಾವ ಥರದಲ್ಲಿ inputs ಅನ್ನ apply ಮಾಡಬಹುದು ಅಂತ. One is the single-ended input. Single-ended input. As you can see here, if you apply the signal to be amplified to one of the terminals and the other terminal is grounded, then this kind of input application is called single-ended input. So if the input signal is applied to only one of the inputs and the other input terminal it is connected to ground, then the operational amplifier is said to be operating in single-ended mode. As you can see here, the input signal is applied to the non-inverting terminal, that is plus terminal, and the negative terminal is grounded. Then the output would be in phase with the input signal. As you can see here, the input signal is applied to the inverting terminal, and the other input terminal, that is the non-inverting terminal, it is connected to ground. In such a case, the output would be 180 degree out of phase with the input signal. So this is single-ended input mode, where the signal to be amplified is applied to only one input terminal, the other input terminal being connected to the ground. Next is the differential mode. Operational amplifiers, they are operated in the differential mode. In the differential mode, two opposite polarity signals are applied to the two inputs of the operational amplifier. As you can see, the signals are applied to both the terminals, that is non-inverting and the inverting terminals. To both the input terminals, the signals are applied. The difference between these two signals, that is VD, which is shown in the picture, VD is nothing but the difference of the two input signals, that is V1 minus V2. It is applied to the operational amplifier. So the operational amplifier amplifies the difference of the two input signals applied at its inputs. So this is the differential mode of operation of the operational amplifier. This is also called double-ended mode of input application. The third one is the common mode. As you can see in the picture, one input signal, it is connected to both the terminals, both the input terminals of the operational amplifier. As you can see here, the input signal that has to be amplified, it is applied to both the terminals of the operational amplifier. So in this case, ideally, zero voltage should be produced at the output of the operational amplifiers, because operational amplifiers, they amplify the difference of the voltage between the ಇನ್ಪುಟ್ ಟರ್ಮಿನಲ್ಸ್. ಬಟ್ ಎರಡೂ ಟರ್ಮಿನಲ್ಗೂ ಸೇಮ್ ಸಿಗ್ನಲ್ ನ ಅಪ್ಲೈ ಮಾಡುವಾಗ ಅದನ್ನ ನಾವು ಕಾಮನ್ ಮೋಡ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ದಿಸ್ ಕಾಮನ್ ಸಿಗ್ನಲ್ಸ್ ಇಟ್ ಇಸ್ ರಿಜೆಕ್ಟೆಡ್ by the operational amplifier, hence the output would be 0 volts. Now let us discuss about the operation of the operational amplifiers. So as I said in the beginning, they are fundamentally a voltage amplifying device. They are designed with external feedback components such as resistors and capacitors between its input and output terminals. So the operational amplifiers, they are operated with feedback components. Usually negative feedback anna ನಾವು use ಮಾಡ್ತೀವಿ. So operational amplifiers, they are used with negative feedback. So feedback circuit nalli we will be having either resistors and capacitors, and these components, that is feedback components, resistors and capacitor, they determine what kind of function the operational amplifier is performing, whether it is differentiation, integration. So all these functions, they are decided by the feedback components. So as I said, op amps, they are most of the time they are operated with negative feedback. That is, output gets fed back to the inverting input through some impedance. So negative feedback nalli output, it is fed back to the inverting input of the operational amplifier. So in a linear operational amplifier, because we have already discussed that operational amplifiers, they are linear devices. So linear devices anta helidre, the output it is multiplied by the amplifier gain and the input. So as we have already discussed, that operational amplifier, it amplifies the difference of the input voltage applied at the inverting and non-inverting terminals. So V1, V2 are the two voltages applied at the two input terminals of the operational amplifier. The difference of this, that is V1 minus V2 multiplied by the amplifier gain, which is called the A, would be the output voltage. So this is the equation which governs the operation of the operational amplifier. So where A is the open loop gain of the amplifier, open loop gain anta helidre, open loop andre when there is no feedback network. So A is the open loop gain of the amplifier, and V1, V2 are the differential input voltages. Andre V1, V2 are the two voltages applied at the two terminals of the operational amplifier. The two terminals, what are those two terminals? They are the inverting input terminal and the other is the non-inverting input terminal. So depending upon the input and the output signals, the operational amplifier gain can be classified as this. That is voltage gain. Voltage gain ide anta helidre, voltage would be the input signal. At the same time, we are getting voltage at the output as well. So the operational amplifier would have the voltage gain. So if the operational amplifier, it is amplifying the current signal, that is current in and current out, then the gain would be current gain. Otherwise, it may also be the conversion type of gain, that is voltage in and current out. So you would be converting voltage to current, that is the operation, it is the transconductance. Similarly, we have the operation of transresistance, where current is converted to voltage. So the operational amplifiers, they can also be used as voltage to current converter and current to voltage converters as well. So students, in this session, we have discussed about the basic definition of operational amplifier, the block diagram, and the operation of operational amplifiers. So based on the discussion, let us have few test MCQs, that is multi-choice questions. We will discuss about one or two multi-choice questions in order to recall the contents of the session. So the first question is, when a differential amplifier is operated single-ended. So single-ended anta helidrenu? Single-ended andre the input signal, it is applied to one of the terminals, the other terminal connected to the ground. So let us see the options. The option A, the output is grounded. Option B, one input is grounded and the signal is applied to the other. Option C, both inputs are connected together. Option D, the output is non-inverted. So as we all know, the option is B. Option B is the right answer. Because in a single-ended, when the operational amplifier is operated in single-ended mode, one input is connected to ground. It may be either non-inverting terminal or it may be inverting terminal. So one input is grounded and the signal is applied to the other input. So the second question is, in common mode. Common mode andrenu? Let's look into the options. Both inputs are grounded. The outputs are connected together. An identical signal appears on both the inputs. Option D is the output signal are in phase. So common mode andrenu? The same signal is applied to both the input terminals. So option C is the right answer. So an operational amplifier can be operated in single-ended mode, common mode and differential mode. So in common mode, identical signal appears on both the inputs. So the third question is, the operational amplifier can amplify. Let's look into the options. AC signals only. Option B, DC signals only. Option C, both AC and DC signals. Option D, neither DC nor AC signals. So in the beginning of the session, I told you that the operational amplifiers are capable of amplifying both AC as well as DC signals. So option C is the right answer. Next, look into the fourth question. With 0 volts on both inputs, an op-amp ideally should have an output of what? When the operational amplifier is applied with 0 volts on both the inputs, obviously the operational amplifier would give rise to an output of 0 volts. So equal to positive supply voltage. Option B equal to the negative supply voltage. Option C equal to 0. Option D equal to common mode rejection ratio. So CMRR, common mode rejection ratio, idr ಬಗ್ಗೆ ನಾವು next session ನಲ್ಲಿ discuss ಮಾಡ್ತೀವಿ. So as I said, when no input applied to the operational amplifier, athwa when 0 volts is applied to both the inputs of the operational amplifier, obviously the output would be equal to 0 volts. So students, let us stop at this stage. So in this session, we have discussed about the basic working of operation of the operational amplifier. In the next session, we will be discussing the various characteristics of operational amplifiers and also the applications of operational amplifiers. So as far as this session is concerned, let's stop at this stage. Thank you.